Sizing the wire gauge for a pull pump circuit depends on the maximum current the circuit is designed to carry, not just the typical current draw of the pull pump itself. In this situation, the disconnect switch is rated for 50 amps, so the wiring must be capable of handling 50 amps. According to the National Electrical Code, specifically focusing on ampacity tables, you would need to use at least 6 American wire gauge copper wire for a 50 amp circuit. This is to ensure safety and prevent overheating of the wires. There's an alternative approach to using 6 American wire gauge wire. You could install a smaller disconnect switch that is appropriately sized for the actual current draw of the pull pump. The pull pump draws 9.6 amps on a 230 volt circuit. The National Electrical Code in Table 310.15 B16 dictates the allowable ampacities of insulated conductors rated up to and including 2000 volts 60 degrees Celsius through 90 degrees Celsius. Let's do an example of how this National Electrical Code table would relate to the pull pump. The most common type of wire used is thermoplastic high heat resistant nylon, which has a 90 degrees Celsius rating. According to the table, a 14 American wire gauge wire can handle 20 amps, a 12 American wire gauge wire can handle 25 amps, a 10 American wire gauge wire can handle 30 amps, an 8 American wire gauge wire can handle 40 amps, and so forth. In this scenario, you could potentially use the smaller disconnect, such as a 20 amp or 30 amp disconnect, and then size the wire accordingly. For 20 amp disconnect, 12 American wire gauge wire is sufficient. For 9.6 amps, you could use a 15 amp breaker as well to stay within the 80% rule. However, it is recommended to use a 20 amp breaker. It's important to note the 80% rule that states you should not exceed 80% of the breaker's rating to prevent nuisance tripping. The 80% rule would be 16 amps out of a 20 amp breaker. For a 30 amp disconnect, 10 American wire gauge wire is sufficient. If you decide to install a smaller disconnect and use wire that is appropriately sized for the actual current draw of the pump, it requires replacing the existing 50 amp disconnect with a smaller one. This may not be cost effective or practical because disconnects are more expensive than wire, and if the 50 amp disconnect is already installed, it might be more efficient to simply use the correct gauge wire for the disconnect. If you do decide to reduce the disconnect size, ensure that the new disconnect is properly rated for the pump's voltage and current requirements. When selecting a smaller disconnect, consider the starting current of the pull pump motor. Motors often draw significantly more current when starting than during normal operation. Ensure the disconnect and breaker can handle this inrush current to prevent nuisance tripping. The National Electrical Code Article 430 covers the requirements for motor circuits, including overcurrent protection and conductor sizing. Consult this article for detailed guidance on selecting the appropriate components for the pull pump motor. Always refer to the pump's nameplate for the exact voltage, amperage, and horsepower ratings. This information is essential for selecting the correct disconnect, breaker, and wire size. Even though the pump does not draw the full 50 amps, it is generally recommended to use 6 American wire gauge copper wire if the disconnect is rated for 50 amps. This ensures that the wiring is capable of handling the potential maximum current draw of the circuit, providing a safety margin and preventing overheating. Replacing the disconnect with a smaller one is an alternative, but it may not be practical or cost-effective. The final decision depends on the specific circumstances, including the cost of materials and labor, as well as adherence to local electrical codes. If you are unsure about any aspect of the wiring process, consult a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. In summary, firstly, determine the maximum current the circuit will carry based on the disconnect rating. Secondly, consult the National Electrical Code ampacity tables to determine the appropriate wire gauge. Thirdly, consider the cost and practicality of replacing the disconnect with a smaller one. Fourthly, ensure all wiring and electrical work complies with local codes and regulations. Fifthly, if in doubt, consult a qualified electrician for assistance. Always prioritize safety when working with electrical systems.